Hello, so today we want to go to another topic that is common in KCSE. I think probably paper 2. It's a topic in form 3, but right now we should not even be, we should be concerned with getting the concept right. We just want to make it simple. It's around 3-4 marks there. It's called binomial expansion. I think if you're in form 4, you must have come across this. So we'll just go straight ahead to questions because I know you have the theory and the mathematics behind binomial expansion. So I'll go ahead and start our work. So sorry, I use the marker to write on the screen, so sometimes it gets to be a lot of work. Now that red is really shouting. So first question that I would write is write down the expansion of. Just before we start the first question, there's something that is so important while dealing with binomial expansion, and it's called the Pascal's triangle. So the Pascal's triangle, this is where we get our values in the different expansions. So the first row is row 0. That is, we have 0, and then this is row 1. Then here, if we have 1, so the next one will be row 2. 1 plus 1 is 2, so this one will be 2. Then the next one will be, here is 3. So this is row 3. Then you have 4. You have 1. So 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. For the fifth one, it will be 1. 1. So 1 plus 4 is 5. 4 plus 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. So this is 5. Row 5. Then the final one, let me go up to 6. Is 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. So, and as you'll see in examples, so we'll be using this as our, during our expansion of those different numbers or different equations. So let's just go to the first question. See how you apply your binomial expansion. So we want to write the expansion. Of 1 plus, sorry for that, let me just write it well. One plus x to the power 6, so that is A. Then B of that question will be use the expansion up to the 4th term. The expansion, 4th term. Expansion up to the 4th term to find the value of, for my handwriting, value of that is 1.03 or 6 to the nearest 1,000. So this is a very important question, and I'm so happy it's the first one. Sorry for that. So I'm so happy it's the first question, and let me just use the red to highlight the difference. So of course, this is the first part of the question that we are going to solve. Then look at the second part of the question. They say use the expansion to the fourth term. This is very important for you to note. You only use it up to the fourth term to find the value of these, of course. Then there is this part to the nearest 1000. So those are some. So the question has this expansion. It has the point where you use it only up to the fourth term, and you find this value to the nearest 1000. So that's a very critical thing for you to know. So we can go straight ahead to the solution. So the solution is 1 plus x to the power of 6. So what happens here is the powers. Now, when you're doing binomial expansion, before you put the binomial coefficients, which we have shown in the Pascal triangle, because this is to the power of 6, of course, we'll use the last line, these binomial coefficients. So one thing I want you to note and remember, because you've already done this in school, is the powers of 1 of the first term will be decreasing as the powers of the second term are increasing. So this will be given as 1 power 6. Sorry, my pen is, let me just change the style. Okay. So 1 plus x. Sorry for that again, sorry for that. So we are saying the powers of the powers of 1 will be decreasing as the powers of x will be increasing. So the first one will be 1 to power 6 times x to power 0. So we start at this point 6. Then plus, the next one is 1 to power 5 x to power 1. Then the next one will be plus 1 to 4 x to power 2. And the next one will be 1 to power 3 x to power 3. Then the next one will be 1 to power 2 x to power 4. Then the next one will be 1 to power 1 x to power 5. And finally, we'll have 1 to power 0 x to power 6. So you're seeing the powers of 1 of the first term are decreasing while the powers of the second term are increasing. So after you get these, you go back to your coefficients and look at the coefficients, which the coefficients here are 6, 1, 6, 15. So our coefficients will be, so the first one, we multiply it by 1. Second one is 6. The third one is 15. The next one is 20. The next one is, sorry, that I hope we'll be able to see. The next one is what? 15. Then here it will be 6. Lastly, 1. So those are the coefficients. So you multiply them by the coefficients. And this one gives us our value as, so 1 to power 6, x to power 0, anything to power 0 is 1. 1 to power of anything is 1. 1 times 1 will be 1. Plus 1 to power 5 is just 1. X to power 1 is just x. So this one will be 6x. And then plus 1 to power 4 is 1. X squared is x squared. So it's 15 x squared. Plus 1 to power 3 is 1. X to power 3 is x cubed. So plus 20 x cubed. Then the next one will be x to power 4, because 1 to power anything is 1. So 15 x to power 4. What's next is 6x to power 5 and plus x to power 6. So that is the next step. You have now your expansion. So at this point, you've completed your first part of the question. You have expanded. Then go back to the question, and they tell you use the expansion up to the fourth term. So B will use your expansion up to the fourth term. So for B, our expansion, which is 1 plus x to power 6, we're only going to use it up to the fourth term, and this is the first term, this is the second term, this is the third term, this is the fourth term. So we'll only take the first 4 terms, that is 1 plus 6x x squared plus 20x cubed. So we'll only do the fourth term. So you use this expansion up to the fourth term to solve this. Look at that. To solve this. So we want to use this expansion to solve this. That means in one way or another, we want to use the 1.1 plus x 6 to solve 1.06. So of course they should be equal for us to use it to solve them. So from here, 6, of course, everything is to power 6. So they literally, if you find the antilog on both sides, the 6 goes away. Of course, 6 never cancels. It's anti-logging. So that is how it disappears. But yeah, they're the same base. The power is the same. So we assume the bases are the same if it for equality to stand. So that means when you cancel those powers, it will be equal to 1.03. So from here, we have our x as what? X as 1 point. Make x your subject of the equation, so it will be 1.03 minus 1, which is 4.0. But remember, they have said what? Use the expansion to solve. So under our expansion, we had copied it here. So that means we'll now say, so we have the value of x, 0.03. Very important. Now our expansion of 1 plus x power 6 to the next 3 terms. I just want to rewrite it here because to avoid having going back and forth. So it's 1 plus x squared plus x cubed. So those are the first 4 terms. So therefore, our 1.03 power 6, we replace x with this value. So it will be 1 plus 6 and 0.03 plus 15 times 0.03 squared plus 20 times 0.03 cubed. I hope you'll allow me. I've not done these sums before, so just doing them for the first time here. So I have to use my calculator to get that answer. So should you in your exam. So that is 1 plus 6 times 0.03 plus 15 times 0.03 squared, squared. I'm using my phone calculator, so in cases you will have your fancy calculator. I hope it will be a little faster than this. But these things, you just get used to them, and they're very easy. Mathematics should never be a problem to you. So we get our final answer, which is 1.1940. So remember, there's this part of the question that said what? To the nearest 1,000th. So to the nearest 1,000th, this is 10th, this is 100th, this is 1,000th. So this answer will be approximately equal to, of course, to the nearest 1000. Let me just write it in the next page. So that will be equal to, of course, it's now an approximation because the whole of this was an approximation, 1.194. 0 is less than 5, so you round down. It is 1, 1, 0. So that was a long example, but I hope it has made sense for you. Let's do the second one. So that is, okay, that's first example. Let's see number 2. And probably try a different case. So let's one A 5, then B, use the expansion to evaluate. Oops. Evaluate. Evaluate what? 0.8 or 5. Correct. I've taken this example because it's going to give us a negative somewhere. So it will be quite interesting because some people don't know how to tackle cases where we have negatives. So one thing, always remember is the Pascal's triangle that gives you the binomial. So this is what gives us the binomial coefficient expansion. So these are called the coefficients. They're the ones we use on our equation. So I hope this second example I'll be a little bit faster. So that is A is 1, 5. So this one, when you expand it, the powers we've said, the powers of the first term decrease from 5, and this one increase from 0. So this one will be, of course, it will be 1 power 5 a to power 0, plus the next one will be 1 to power 4 a to power 1. Then the next one will be 1 to power 3 a squared. Then the next one will be 1 to power 2 a cubed. Then the next one will be 1 to power 1 a to power 4. The next one will be, let me just move that one a bit. The next one will be 1 to power 0, then a to power 5. Then the next thing you need to include here are the binomial coefficients. And for 5, I hope these things, when you do so many examples, you just remember them. For 5 is 1, 5, 10, 10, 5, 1. So this is where you check your binomial coefficients for 5. This is their line. So these are the coefficients. So 1, 5, 10, 10, 5. Just do them with red so that 1, 5, 10, 10, 5, 1. So sorry, I know the signs have disappeared in some cases. So anything 1 to power something is 1, and 0 to 8, anything to power 0 is just 1. So this one will be 1 plus 8 power 1 is just a, so it's 5a. Then 8 power 2 is a squared, of course. 8 power 3 is 10. Of course, 1 to power anything is 1. Always remember that. Plus 8 power 4. 8 power 4 is 8 power 4 ni nini? So it's 5, 8 power 4 plus 8 power 5. 1 to power 0. Anything to power 0 is 1. So you have your expansion. Then now we use the expansion to solve what? At B. Use the expansion to solve 0.85. So to use this expansion to solve 0.8 power 5, you have to equate it to that, to this initial expansion, to the initial value, because they are all to power 5. So it's 1 plus a power 5. These powers should be the same, or else you will need to use so many rules, which I don't think at your level you're doing that. So that means from here, 0.8 plus a. So we can make a the subject. When 1 crosses this side, it becomes 0.8 minus 1, which gives us our value of a as, sorry, should you work, the value of a as negative 0.2. So this is what we'll use for substitution, negative 0.2. So it's 1 plus 5a. So we'll substitute where there is a in that equation to with 0.2. So 0.8 or 5, of course, will be 1 plus a is negative 0.2, 10. So the next is 10a squared, then 10a cubed. So negative 0.2 squared, 10, 0.2, sorry for that, 0.2 cubed, then plus what next is 5, 0.2 power 4 plus 8 power 5. You have substituted your values there. So you're using it for expansion of this value. Now, what do you get? Let me do it again on my calculator. I didn't do it then before because I have some engineering to do. 0.2. Sorry, as I do this, you might be trying also on your side to see what the answer is, because I might put in a wrong answer. Who said engineers are always right? 0.2 squared plus 2 cubed. You know, the phone calculator, it's never the best. And never try going with the phone in an exam. Never. It's an offense, very illegal and unethical. Negative 0.2. And one thing, never fear the math. Just do it. It's simple. When you do practice, you get it. I hope we are right. So I've gotten 0.3768. Now to 4 decimal places, this is 1, 2, 3, 4. This is above 5, so we round up. So it's 0.3277. 5 decimal places. Let me just confirm if we are correct. 0.8 to power 5. Yeah, we are correct. So we've used the binomial. The good thing about binomial expansion, after doing and getting this answer, just confirm, expand this fx. It's always what, fx 991 or something, fx 82. See whether you're getting the right answer, whether this answer is correct, but don't use the calculator. Just use binomial expansions. And then, of course, these ones you can expand with the calculator. Then maybe do one more. One more. Number 3. Let me find a good one. So they say this is also set in a different way, but just exactly the same as the first one. So they say expand 2x to power 5 in sending powers of x, as they should be, of course. We have said powers of x will be ascending up to the term in x power 3. Hence approximate the value of what? Of 2.03 power 5 or significant. So interesting. So the other one was to 1,000. The next one was to decimal places. This one is to significant figures. People write that for SF. This question is about 4 marks, 4 free marks. Always remember Pascal Triangle. The good thing, you have Pascal's Triangle to get binomial expansion on your 4-figure mathematical table. So let's get to this. We are then doing 5. We don't even need A and B. Okay, my laptop is going. Sorry for that. Let's keep this going. So it is 2 5, and this one in ascending powers of x, descending powers of 2. So this will be 2 power 5 x power 0 plus 2 to power 4 x to power 1 plus 2 to power 3 x power 2 plus 2 to power 2 x power 3. Remember the question, they said what? Up to the term in x to power 3. So when you get to x to power 3, you stop. Do not proceed because you will not be following instructions. Just plus those 3 dots that shows this thing is still going on. So stop there. Don't be a genius. Then remember, now we use our binomial coefficients from Pascal's triangle. 5. So it's 1, 5, 10, 10, 5, 1. So those are our binomial coefficients. We'll do them with a different color so that you don't confuse. So the first one is 1, the second one is 5, the third one is 10, it's 10. Yeah, so this one, of course, when you expand this work, so 2 to power 5 is 32, x to power 0 is 1, so is 1. So 32 times 1 is just plus 5 to power 2 to power 4 is 16. X to power 1 is x. 16 times 5. Yeah, that one I have to go to my calculator, my people. 16 times 5. Sorry, I'm an engineer, but hiyo lazima tukumbushane. So it's 80 x. Then plus 2 to power 3 is 8 times 10 is 2x squared. And plus 2 to power 2 is 4 times 10 is 40 x cubed dot dot dot. So you have your expansion. Now after having expansion, what next? We have said use your expansion to solve something. 2.0345. So use it to solve this. So you equate this value and this one because you're using this to solve this, so they should be equal. So you'll say 2 plus x power 5 should be equal to what? 2.0345. So from here, 2 plus x 2 point. So here you can get x. The subject, it will be what? 0.03 minus 2, which is equals to 0.03. So you have your value of x. So your x, this is the one that you're substituting. So you come and bring back our equation here. So we say, therefore, 2.03 5 will be 32 plus 80x. 80x, our x is 0.03 plus 80x squared. X squared is 0.03 plus 40x cubed. 40x cubed. 40 cubed, then plus dot. So what is your approximate answer? So let me go back to my calculator. So hapo ndio tunaitwa washikadau. So that's 32 plus 80 times 0.03 plus 80 times 0.03 squared. Sorry. Okay, squared plus 40 times 0.03 cubed. So you have your answer as 4.13. Now we need this answer to 4 significant figures. So a figure is significant, one, if it's on the, of course, all the figures on the left side of the decimal place are significant. So we start from the counting from the left. So to 4 significant figures, we have 1, 2, 1 is 4.7. Answer to 4 significant figures. So you have solved your problem. I hope that was enlightening, and I look forward to seeing you in our next video. So one thing in mathematics, just do a lot of practice. It was quite simple, and trust me, when things appear to be a little bit harder, you're not alone. What it's just telling is just do more practice. So the more practice you do, the better it becomes. And this translates to all the other subjects. I hope you get the best marks in your KCSE, and you're going to ace this exam. And ensure you do the same for all the other subjects. Okay, I will do, these are past KCSE questions. So next time we will be doing another one on the next topic. So we'll keep this going and helping one another. Have a great, for me it's here, so have a nice time, and God bless all of you.